Y'all ready? So we're talking about forces and motion. This unit is very going to be very short. You will talk about contact forces in the spring, so we're not going to go too heavily into this because we're moving into metabolic stuff. So more stuff with cells. Um, and I am finishing up the the two reviews. I'm grading those, the two yellow papers we did with your partner. Um, I'm grading those. So the people who chose not to work with your partner, oh yeah, I need my phone for time. You chose violence. So I don't know what to tell you based on your grade. Um, your open responses that you did on the cells, there will be redos on those. So if you do get a redo for any reason, you need to redo it and turn it back in for a grade. Just saying. Because if not, the grade that you have will stand. So if you didn't answer any of the parts of the question and you get a zero, I'm giving you a chance to redo it. And if you choose not to redo it, the zero stands. There's no negotiations. Because I gave you heads up, giving you plenty of time, and you can do it during sixth period when you're in the room. So if you're in second, do it on Monday, third, do it on Tuesday, fourth, Wednesday, fifth, Thursday. Um, or when you're in your normal sixth period on Friday, you can still do it and turn it in. But we are not using class time to make up work. You have sixth period. So we're going to push our sixth grade review back so that people can make up their work. If you are absent, make sure that you get your work. Um, if not, then you won't get a grade. Um, hmm. So let's get this part started. Share. Oops. Physical science is pretty much chemistry and physics rolled into one. Um, that's all that it is. Motions and forces. So we will be doing some math. There's math and physics. Physics has a lot of math, actually. Um, so we will be doing measurements. So we will be working with rulers a lot. Um, so I need to find some more meter stick, Erasmus, Wimpy. Distance, when you formulate how far in distance it is, you are using fractions. So there's a lot of math and physics. These are different parts that we're going to be talking about during this unit. Um, we're not going to touch on all of it, but we'll touch on some of it. So, what is force and measurements of use? Let's see. So, what is a Newton? Newton, I'm going to do that. So write this down. A force is a push or pull or any action that has the ability to change a motion. The key word here is action. Force is an action. So if there's a monsoon, a tornado, hurricane, that's a force because it is pushing. If you were sitting in a car and a magnet is in front of your car and it's pulling your car, or if a rope is tied up to it, especially to a tow truck, and it's pulling your car, that is force. Um, any type of action can be a force. So as you see, some of the causes of force are muscles, moving matter like wind, water, and massive objects like planets. So the planets moving around in the solar system, regardless if it is our planets in the Milky Way galaxy or outside of the Milky Way, everything takes force. The Earth rotating around the sun takes force. Um, Throwing a ball from the front of the classroom to the back of the classroom is force. So go ahead and write this part down. Fundamentally, forces come from interaction between atoms and other energies. Atoms, when you mix them together, especially if depending on their different bonds. Um, and sadly, y'all did study Allen in sixth grade, but atoms, when they bounce around, they cause different forces. That's why you shouldn't mix certain chemicals, certain elements, because the reactions from them will cause different chain reactions that any action is force. So regardless if it's a positive, negative, or a neutral, it's always a force. Um, So these are the basic forces. So now, if you wrote down the strong nuclear force, don't write it down again. Um, it was on the previous slide. Um, but the electromagnetic force. So, like if you use magnets, for instance, there's usually a positive charge and a negative charge. Those forces are held together by atoms um, into molecules, but a negative and a negative charge won't come together just like a positive. It has to be a negative on positive. Weak force, radioactivity. Um, Gravity causes all mass to attract each other. Your weight comes from the mass of the earth attracting the mass of your body. So the gravity pretty much, in layman's term, the gravity keeps you on Earth. It keeps you from floating in outer space or just floating around the world. And the weight of it is ridiculous. We don't notice it, but there's a heavy weight that keeps us from floating off. So make sure you write the electromagnetic force, the weak force, and the gravity. Um, don't write don't write the strong nuclear force. When you measure the weight in pounds on a scale, you're measuring the force of gravity acting on the object. So the word pound comes from the Latin word pundus, which means weight. Um, this is what I was telling you about how the gravity holds you down, and you can never, like, you can still move around, but the gravity has enough force to where um, you can't fly around at all. So weight is a very important part of physics. Um, because not only do you have to measure distance and the speed, but weighing stuff can also throw off, let's say, an experiment. If your water weighs 5 pounds versus 1 pound, the force to move 1 to 5 pounds is way different from, if I'm moving 1 pound of water, it's not going to be that difficult. But moving five might be just a tad bit. Um, So the Newton and the symbol for Newton is N is a metric of unit of force. So we will go in, not today, but we will go into detail how to use Newton properly. This is what I was trying to explain to y'all earlier, that there's a lot of math. So 1 Newton is the force it takes to change the speed of a 1 kilogram, that's what kg means, mass by 1 minute/second in 1 second. So you don't have to write the pictures, just make sure that you write down the Newton is the metric of the unit force, and that's it. So right where the bullet point is. Don't draw the pictures and don't write the other stuff under the Newtons. This is showing you another example of Newton, but we will go back over this in more detail. And I think I'm going to print out a formula sheet of the different formulas and stuff for physics, because they are a lot of them and also hard to memorize. So converting newtons into pounds, 1 pound of force equals 4.48 of newtons. Um, don't have to write this down, but we will go over that. So gravity and weight. The force of the gravity on any object is called weight. So when we jump on a scale, that is the weight that is on you. Mass and weight are not the same. Mass is something like the mass of a whale is different than the weight. So the mass is how big it is around, but when it comes to weight, it's um, a whole different measurement. So you see 1 kilogram equals 9.8 newtons, 2 kilograms equals 19.6, and 3 kilograms equal 29.4 newtons. At the Earth's surface, each kilogram of mass feels 9.8 newtons of weight from Earth's gravity. So make sure you just write the bullet points. Don't draw the pictures, just write the bullet points. So in this example, a kilogram rock has the 10-kilogram rock has a mass of 10 kilograms no matter where it is in the universe. That spring that they're holding, that measures the Newton. So that rock's weight, however, can vary greatly depending on where it is. So on Earth, where there's more force, it now weighs 98 newtons. And on the moon, it weighs 16 newtons because there's less gravity to hold on to the rock. So don't write this down. It's just an example. Um, but write this down. So this is the formula for weight. So you want to take the mass, kilogram, which is the M, multiply it by the strength of gravity, so the N/kg, which is Newton/kilogram, equals the weight So the weight equation can be, so look at the different forms of the equation. Um, don't write this down. I will give the rest of them to you. I just wanted you to write that one down. Um, but these are different ways to find. So use W equals mg if you wanted to find the weight. So you will have to know the mass and the strength of the gravity to figure out how much it weighs. Um, if you want to find out the mass, you will take the weight and the strength of the gravity and divide them. So also, if you wanted to find the strength of the gravity, you take the weight and the mass and you divide those two numbers together. That will give you the strength of the gravity. So a force vector has units of newtons just like all forces, but also includes enough information to tell the direction of the force. So if something's being pushed one way, it could be plus 10 newtons, or if it is pushed the opposite way, it's a negative 10 newtons. So just make sure you just write down the bullet point.